In this video, we will discuss the law of sines.
An oblique triangle is a triangle that does not contain a right angle. Because these triangles do not have right angles, we cannot use the Pythagorean theorem or trigonometric functions directly as we did previously to find sides and angles of right triangles. However, two formulas based on the trigonometric functions of right triangles can be used to solve oblique triangles. The first is the law of sines. The law of sine states that the ratios of the sides of a triangle to the sines of the angles opposite these respective sides are equal. So A over sine A equals B over sine B equals C over sine C. The law of sines can be used to solve triangles when either of these conditions exist. First, two angles and a side are known, or second, two sides and the angle opposite one of the sides are known. When using the law of sines, you must have at least one complete ratio, an angle and side opposite. However, if we know two angles of a triangle, we can always find the third angle. Then we can form a complete ratio. To find the unknown parts of an oblique triangle given two angles and a side, first find the third angle of the triangle by adding the two known angles and subtracting the sum from 180 degrees or 2 pi radians. Then set up the ratio with the given side and sine of the opposite angle. Set up a second ratio with an unknown side and the sine of the opposite angle. Form a proportion using the ratios in steps 2 and 3 to solve the proportion for the unknown side, and repeat steps 2 through 4 if the value of the third side is needed. Solve triangle ABC if A equals 50 degrees, B equals 75 degrees, and B, lowercase b, the length of the side, is 12 feet. First, we find angle C. We know that A plus B plus C is equal to 180 degrees. That's 50 plus 75 plus C equals 180 degrees. So C equals 180 degrees minus 125 degrees, which is 55 degrees. Then we can find side A. By the law of sines, A divided by sine of capital A equals B divided by sine of capital B. So that's A over sine 50 equals 12 over sine 75. Which means, cross multiplying, that A times sine of 75 degrees equals 12 times sine of 50 degrees. So A is 12 sine 50 over sine 75, which gives us 9.51681,081, or about 9.517 feet. Now find side C. B over sine B equals C over sine C. So 12 over sine 75 equals C over sine 55. 12 times sine 55 equals C times sine 75. So C equals 12 sine 55 over sine 75, which equals 10.1765832, or approximately 10.18 feet. As a quick check, the longest side should be opposite the largest angle and the short side should be opposite the smallest angle. And here is the solved triangle. Solve triangle ABC if A equals 35 degrees, lowercase a equals 7 centimeters, and B equals 40 degrees. First, we find angle C. A plus B plus C equals 180 degrees. So 35 degrees plus 40 degrees plus C equals 180 degrees. C equals 180 degrees minus 35 degrees minus 40 degrees, which is 105 degrees. Find B. A over sine A equals B over sine B. So 7 over sine 35 equals B over sine 40. That gives us B equals 7 sine 40 over sine 35, which is 7.844661989, or about 7.845 centimeters. We find C the same way. 7 over sine 35 equals C over sine 105. C equals 7 sine 105 over sine 35, which is 11.79 centimeters approximately. Finding unknown parts of an oblique triangle given two sides and an angle. When two sides of a triangle and an angle opposite one of the sides are known, we do not always have a single triangle. If the given sides are A and B and the given angle is capital B, three possibilities may exist. If B is less than A and angle A is not equal to 90 degrees, we have two possible solutions, as in case 1 here. If B is less than A and angle A equals 90 degrees, we have one solution. And if B is greater than or equal to A, we have one solution. Because of the lack of clarity when two sides and an angle opposite one of them are given, the situation is called the ambiguous case, meaning that the given information can be interpreted in more than one way. To find the unknown parts of an oblique triangle given two sides and an angle opposite one of them, first use the law of sines to find the measure of the angle opposite the other side. Then determine if there are two angle values that are possible for the solution. Find the third angle by subtracting the sum of the two known angles from 180 degrees. Find the third side using the law of sines. If two angles were found in step 2, find the second possible solution by repeating steps 3 and 4. Solve triangle ABC if A equals 25 degrees, lowercase a equals 8, and lowercase b equals 11.426. First, we find angle B. A over sine A equals B over sine B. So 8 over sine 25 equals 11.426 over sine B. That is, sine B equals 11.426 times sine 25 over 8, which is 0.60360454323. B is equal to the inverse sine of 0.60360454323, which is about 37.1 degrees. But B is less than 90 degrees, so there are two possible solutions. It should be A is less than 90 degrees, two possible solutions. We find angle C. C is 180 degrees minus 25 degrees plus 37.1 degrees, which is equal to 117.87158082 degrees. And we find side C, C equals 8 sine 117.87158082 divided by sine 25, which is about 16.73 degrees. So here's the completed triangle, the solved triangle, if B is 37.1 degrees. Now observe that for all angles theta, 0 is less than 90 is less than theta is less than 90. Sine theta equals sine of 180 minus theta. So sine of 37.1 is equal to sine of 180 minus 37.1, which is sine of 142.9 degrees. We say B prime equals 142.9 degrees, and this is the other possible angle opposite side B. So to find angle C, C prime is 180 minus 25 plus 142.9, which is 12.1 degrees. So finding C prime, the side, C prime equals 8 sine 12.1 over sine 25, which is about 3.977. And here is that completed triangle. Solve triangle ABC if B equals 10, C equals lowercase c equals 12, and capital C equals 40. Here is the initial triangle with the information we're given. Because C, the side opposite the given angle, is longer than the other given side, B, there is only one solution. So we find B, sine B equals 10 sine 40 over 12. I've just solved that for sine B from the beginning. That's going to give us sine B equals 0.53565634414. We take the inverse sine of both sides to get B is about 32.4 degrees. Then we find A. A is 180 degrees minus 40 degrees plus 32.4 degrees gives us 7.6 degrees. So side A is 12 sine 107.6 over the sine of 40, which is about 17.79. And here is the solved triangle.